Learn about distributions. First, let's talk about normal distribution. In a normal distribution, the distribution is a bell curve shaped, symmetric, and there is no skewness apparent. In a normal distribution, the mean, median, and mode are all at the same place, which is the center of the distribution. If there are a lot of outliers of extremely small values, a normal distribution will become a left-skewed distribution. A left-skewed distribution has a long tail on the left. How do I know those are small values? Well, because on the x-axis, the values that closer to the left side or to the 0 point are smaller values. They are 0, 1, 2, 3, 4. While the values further down the right-hand side are larger values, as indicated in the figure on the right-hand side. Well, in a left-skewed distribution, the mean will be dragged to the left side, same as the median, but the mode is not likely to change, so the mode will stay in the same place. If there are a lot of outliers of extremely large values, a normal distribution will become a right-skewed distribution. In this case, the mean will be dragged to the right side, same as the median, but the mode will not change. Let's talk about the range. Range means the gap or the distance between the largest value and the smallest value. For example, in group 1, there are 1, 4, and 7. So the range is 7 minus 1 equals to 6. So for the second group, 3, 4, 5, the range would be 5 minus 3 equals to 2. Therefore, group 2, the range of group 2 is 2, while the range of group 1 is 6. So group 2 has a smaller range than group 1. Variance measures the average amount of difference between values. It illustrates how scattered the different cases are in the dataset. Standard deviation is also a measure of how spread out the numbers are in the dataset. Mathematically, standard deviation is the square root of the variance. Please take a look at the equations of the variance on the slide. For example, to calculate a variance for the first dataset 1, 4, and 7. The first step is to calculate the mean. So 1 plus 4 plus 7 and then divided by 3 equals 4. The second step would be to calculate the difference between each value and the mean. That is 1 minus 4 or 4 minus 4 or 7 minus 4. So those are the difference between each value and the mean. And then square all these values. The third step is combine all the square values together. Last step, divided the combined value by 3, which are the number of cases. For 3 is the number of cases in this dataset. So taking them together, the variance of this dataset is 6. So for the second dataset, we can calculate the variance in a similar way. You can practice to see if you can calculate the same variance as I do, which is 0.67. Based on the variance values, 6 is larger than 0.67, so the first dataset is more scattered or spread out than the second dataset. In fact, you don't need to memorize the equations for variance or standard deviation. You only need to know that both variance and standard deviation are indicators of how spread out the data points are. So what does standard deviation or SD mean? Well, you will see a standard deviation or SD most often when researchers describe the dataset. So standard deviation is the average distance between any point and the mean. The smaller the standard deviation, the closer the data points are to the mean, and thus the narrower the distribution is. Well, larger the standard deviation, the further away the data points are to the mean, and the distribution becomes more spread out. We should be able to identify the distribution of a dataset by looking at the histogram. A histogram is a graphical display of data using bars of different heights. In a histogram, each bar groups numbers into ranges. Taller bars shows more data fall into this range. For example, in this histogram, we look at the y-axis and the x-axis. The y-axis illustrates the number of students, while the x-axis illustrates the exam scores. From this histogram, the highest bar is the orange bar, indicating there are more than 50 students have the score between 50 to 60. And a blue bar shows that there are less than 10 students who have the score between 0 to 10. Here comes a question for you to think about. How many students in this class whose scores are between 70 to 80?